Say 7x minus 5x and minus 2x is not yes 9x. Yeah, yes, that's supposed to happen. Okay, so that's good. Means you got it right. Yes. Someone's talking to me. Yes. Okay. Just complaining. Okay. All right, so let's look at this one here. If something weird is happening, that's good. Something weird is supposed to happen here. So here, let's keep all the x's on one side. 2x, where can we find another one? The other side has a 7. We'll bring it here as a minus 7. There's a 5 on the other side. We'll bring it. There's a minus 5. We bring it as a plus 5. Okay, on the other side, we have a 5, and we bring a minus 12 and a plus 8. Again, just rearranging. Okay, left-hand side, we have minus 7 plus 5. So basically, minus 7 plus 7 gives us 0x. On this side, we get 8 and 5 is 13, minus 12 is 1. So 0x is the same as 0, is equal to 1. Okay. Did you guys get something like that? Now, the question is this a valid statement? It isn't, right? But we did everything mathematically correct. We didn't cheat anywhere, and we end up with something which is not true. So we got to know how to deal with these cases. Whenever we get something which is not true, so if we get a false statement, it means that there is no solution. There is no value of x for which this equation is valid, is what we're saying. There's no solution. Okay. So this is just something we have to remember. Whenever you get a false statement, that it doesn't have to be 0 is equal to 1. It could be anything false. 2 is equal to 30, 5 is equal to 20, whatever. As long as it's a false statement at the end, then there's no solution. Okay, so let me just look at one more thing here to try to get a better intuitive feel rather than a mathematical feel. Okay, let me give you guys a moment if you're writing down before I do this, because this is important. How's our time? We're so good. Okay, so I'm going to make up another example which has more intuition to it. Let's suppose I wrote something like x is equal to x plus 1, and I told you to solve for x. This clearly would give you no solution as well, right? But if you just look at it, it doesn't make sense as an equation. So we know it's broken just by looking at it, because how can x be the same as itself plus 1? Right? It can't be true. We're saying x is equal to the same as itself, but it's now different because we're adding 1. So this definitely cannot be true. So that by construction is a broken equation. If you solve it, you'll see it doesn't work. Solve it very quickly. We get on this side x minus x is equal to 1, or 0x is equal to 1, 0 is equal to 1. Same situation, broken equation doesn't work, so there's no solution. Okay, all right, any questions on this? Okay, so again, I'm going to try and go a bit quicker. You guys can try. You guys want to try this example before I move on? Should be the same thing. You'll get no solution. Okay, you guys want to try it at home? Okay, skip ahead. And here is the rule. When you arrive at a false statement, I gave a general statement that A is equal to B. A and B are not the same thing, so this is a false statement. Then there's no solution. Okay. All right, now another weird thing needs to happen here. So I'll ask you guys to try the first example here. Give you guys 30 seconds to do that. It won't take long. Did you guys all get the same answer? Yeah. Okay. Right. So if you, the rule here is if you get a true statement at the end, which tells you nothing about the variable. So this tells us nothing about x, but it's true. Then there are infinitely many solutions. So we'll just write it as infinitely many solutions. In other words, it doesn't matter what value of x you choose. You can substitute any value of x into this equation, and you will always get left-hand side equal to right-hand side. It's a bit of a strange thing. It's like a perfect equation. It works for any value of x. And again, we can come up with a more intuitive example to understand instead of just mathematically. An equation, something like this, x is equal to x, for example. This is an example of a perfect equation. No matter what value of x you plug in here, you will always get left-hand side equal to right-hand side. It's clear from this one, right? No matter what you put in here, it will always work. And if you try and solve it, you'll end up with the same situation. You'll end up with x minus x is equal to 0, 0x is equal to 0, or 0 is equal to 0, which means it's perfect. You can plug anything in and you will get left-hand side equal to right-hand side. So this also has infinitely many solutions. Okay, do you guys want to try another example or do it at home? At home, okay, perfect. Let's do that at home. Solving inequalities. So at this point, we know what inequalities are. We just need to know how to solve them. We need to know how to plot them. I think we do. Yes, we do plot them. Okay. So I'm going to do the first one with you guys. Solving inequalities. The only difference here is sometimes the inequality sign changes if we multiply or divide by negative. Otherwise, it's exactly the same as equations. Okay, and we'll see that situation come up at some point. But for now, to solve something like this, firstly we solve, then we plot, and the plot usually covers like a fair amount of marks, maybe 5, 6 marks, something like that, or just drawing a number line and plotting. So find the solution first. Let's just move all the numbers to one side. So 5 minus 3 on this side, x is less than 2. Right? You guys agree with that part? That's the solution. It's usually just like an equation, no different. Got a solution. Then we have to draw a number line, which you guys probably know how to do at this point. Just draw a number line, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and so on, whatever. Now we will go to our solution, which is 0, and we will draw an open circle at 0. We draw an open circle, but if this was less than equal to 2, then we draw a colored in circle. Okay, so that's just a slight difference there. Open circle because it's just less than 2. And now we draw an arrow pointing in the direction of our inequality. So we draw an arrow in this direction. This direction. Try and make it as straight as you can, straighter than my one. So that's all you have to do to plot the solution, right? It's like nothing. So, yes. This arrow or the numbers you just stop it at the end of the number line. Because you draw an arrow here, it implies it's going on forever. Yes.
It will be technical question.
Yes.
You conduct a number line, how do you find the number 3, you have to show the line section. How many number difficulties you can how do you find the 2D? If you have one integer, you are able to double example.
Yeah, so good question, guys. I'll repeat the question. How many numbers do we need to show in the number line? Generally, just show whatever your number is, you just need to show at least 2 on each side of it. That's good enough. Okay. I mean, I usually draw a number line with a lot of numbers, but what minimum you just need to show 2 on either side. That's good enough. Then I know that you know your orientation and we'll be fine.
And you have to express it with arrow above the number line, or if it's above the number line to
above is fine.
Fine. Yeah.
Some of you guys prefer drawing the arrow above the line. I think you did that in high school, some of you. Yeah, so if you want to do that, that's fine. That's still correct. Okay, and one example to show a colored in circle, I guess. So this one here, I'm just going to do this one quickly, right? You guys can try and do it with me if you want. Let's make it fun. Let's have a race and see who finishes first. 3, 2, 1, go. This one on top. Guys are competitive here. Very good. X less than equal to minus 12 plus 10 less than equal to minus 2. Yeah. Oh, sorry, guys. Okay, I'll give you guys a moment to do the number line. Number line, yeah. We're doing number lines in university. You guys probably think you can go to P&A now, buy your highlighters, including all the colors, everything. Everyone in agreement with what's on the board? Okay, take a moment. Okay, guys, I'm not going to do too many of these because I think they're straightforward. Anyone has questions before I move on? All right, more examples to try. Okay, I should probably do one of these where you check the solution because I'm not sure if you guys would have seen this before. It's just a bit of a thing to remember how to check solutions. With equations, you guys know how to check solutions. I hope so. All right, so to check a solution with an equation, you just plug in your solution and check if left-hand side equals to right-hand side. You guys seen that before? That's what you do with an equation. With an inequality, it's slightly different. So I'll show you guys. It's a two-step method. Okay, so here we know the solution already because we just worked this one out. It was x less than equal to minus 2. Like we just worked this one out. Now to check the solution, so step 1 would be, I'm going to do this slowly, would be to write your original inequality as an equation. X minus 10 is equal to minus 12. And to write your solution as well as an equation. X is equal to minus 2. That's the first step. Then we substitute the solution into the equation and check if left-hand side equals to right-hand side. So it's like checking an equation. So I'll draw this with arrows. So I sub that into there and check whether we get something that makes sense. So when I do that, we end up on the left-hand side with minus 2, minus 10, and the right-hand side is still minus 12. So minus 12 equals to minus 12, which means left-hand side equals to right-hand side. And we're happy that check has passed. Step 1 makes sense to you guys? Okay. All right. Now step 2 is a little bit stupid, but we have to know how to do it. In step 2, we need to pick a random value of x which satisfies this inequality here, satisfies our answer. So I'm going to say, maybe I should write that. Pick random x that satisfies our solution. Okay, so do you guys have a proposed x that you can use? Anything, it could be any number. Anything that satisfies this inequality. So basically anything less than equal to -2. -5, we can go with -5. Okay, so right here, we pick x is equal to -5. Then you plug this into the original inequality. So right here. So then you plug into the original inequality, which is x minus 10 less than equal to -12, and check if you end up getting a true statement, which I can see in this case we will. So we end up getting here -5 minus 10 less than equal to -12. Or -15 less than equal to -12. That's our final. Is that a true statement? Yes, it is. All right, so this is true. Now, some people get confused looking at these negatives like this. So what you can do is just multiply throughout by negative if you want to, and you can end up getting 15 greater than equal to 12, which is much easier to see that it's correct. So you can do either one, top or the bottom. Let's just take note of this method, the two-step method, because the module manual makes this a whole big song and dance thing, which is not necessary. It's just an easy two-step thing to remember. Yes. We will. We will. Do you guys remember the test date? The test date? March 27th. Okay, we got some time. It's March 27th. Just learning. This is learning unit 2. Learning unit 1 is all the easy stuff. Yes. At the bottom here. Okay. Yeah. That's right. That's exactly right. Okay, any questions before I move on? Okay. All right. And here's the note we just mentioned. When you multiply or divide both sides by a negative number, then you need to flip the sign of the inequality. So again, you guys can practice with those. Let's see if we go right to the end. Do you guys want to do one slightly difficult example? Try this one. Okay, I'll give you guys a few minutes. That's it. Okay. So this is the last thing in this section. So try to save it, enjoy it. I don't know. Okay, guys, I'm going to do this one on the board now. Hopefully it's not too long and we can finish. I think this will be the last example we do today. So just bear with me. I'll finish it as quickly as I can because then we got a new section and I don't know if you guys are ready for a new section today. Okay, so I'll do this quickly. 3/5 times 2d minus 3/5 times 5 less than or equal to 4 times 7 minus 4/5d. Okay, so all I did is I just opened up all the brackets on the left-hand side and the right-hand side. Left-hand side, we will end up here with 3 times 2 on the top, which is 6d/5. Minus these 5s here will cancel out, I guess, and then we're left with 3. Okay, on this side, we have 7, 14, 21, 28 minus 4d/5. So the d's have a common denominator, which is helpful. Let me just put them together. So on the left, we have a 6d/5. We can bring the 1 from the other side, which gives us a positive 4d/5. Then we have 28 plus 3 on the right-hand side. Now let's move this up here. Left-hand side, 6 plus 4 will give us 10d/5 less than or equal to 28, 29, 30, 31 on this side. Okay, 10/5 is just going to be 2. So this is 2d less than or equal to 31, sorry. Or divide by 2 on both sides and we get d less than or equal to 31/2. Okay, you guys in agreement with that?
Yes.
Okay, all good. Now, first with these, you have to know how to plot them. So plotting something like this, it's always helpful to rewrite the number as a decimal. Right, so 31/2 is 31 divided, basically half of 31, 15,5, right? Okay, so 15,5, and from there we know where that goes on a number line. So let's start it like this. We'll go 15, 16, 17, 18, 14, 13. Right, that's good enough. Where are we? We are at 15,5, which is somewhere here. Closed circle because it's including that, and then we just go that way. Okay, straightforward stuff. Any questions? Okay, then I will set you guys free today. And yeah, I'll see you guys next time.